In order to be able to deploy NSX, we need to have distributed switches, and distributed switches have a lot of different configuration options, far more than a standard switch. So in this nugget, I'm looking forward to taking just a little bit of time with you to focus on those distributed switch policies that'll help to ensure our best NSX deployment. We're using VMware Lab HOL 190301 getting started. Once you've logged on, let's just fire up Google Chrome, and we'll log in to the vCenter single sign-on as administrator vsphere.local with the default password of VMware !! We're going to head over to the networking tab in the navigator. Let's expand region A1, and then we'll select the compute distributed switch. Let's hop over to the configure tab, and the first and foremost option that we must pay attention to is the maximum transmission unit size, which isn't really a policy, it's more of a configuration, but we need to make sure that under advanced it says 1600 or greater, or we're not going to be able to support the VXLAN encapsulation that is so important to us. Let's go ahead and click OK out of that. So at a high switch level, we have some core settings we can configure, such as being able to point NetFlow collection to a specific NetFlow collector. So the gathering of IP and port-based connections between different endpoints is what NetFlow collects, but it's important to remember that vSphere is not about collecting that data, it's about sending that data to a centralized collector. Let's expand our switch on the left-hand side, and we're going to be looking at policy configuration, and policy configuration can be done at the port group or uplink group level, or at an individual port level if we want to dig down to that point. Let's select our D port group as a pretty safe example to work with. On the Configure tab, we can see Policies. So this is the configuration we want to focus on right now. Let's click Edit. So on the left-hand side, let's head over to Advanced. And the Advanced is really kind of the main master toggle switch. But sometimes folks get confused about this. This is not whether or not we are turning on or off these settings, because those configurations and settings are done in the respective nodes over here on the left. No, what this is asking is if it is okay to override the port group policies with individual port policies. The only policy that's allowed to be overridden at the port level is the ability for that port to be blocked. But if we would like to be able to change some of the security settings or VLAN settings at an individual port level, then we would come here to allow that to happen. On the left-hand side, let's hop over to security. So the security settings that we're relating to here determine whether or not we allow for promiscuous mode, which would mean that all of the ports in that particular port group will function more like a hub, in that any communication that goes to a specific node in that particular port group will actually go to all the nodes in the port group. That is used in particular when working with IDS and IPS and other types of monitoring tools. Then under MAC address changes and forged transmits, we have the question of whether a virtual machine is allowed to push out a message with a MAC address that is different than what is configured in that VM's file. Because every virtual machine gets assigned a MAC address to its virtual NIC, and that MAC address is registered in the properties of that virtual machine file. It's that specific MAC address which is stored in the MAC table of a virtual switch, whether it's a standard or distributed virtual switch, which means that unlike physical switches, which learn MAC addresses dynamically by the process of communication, a virtual switch has a hard-coded entry for what MAC addresses are in place. So if I go into that virtual machine and change the MAC address in the software configuration, that's going to be a different MAC address. If I'm using a piece of software like Microsoft Network Load Balancing, which registers an additional MAC address to what you have by default, then that would be a different MAC address than what the switch is expecting. And by default, any attempt to leave that interface or receive traffic to that MAC address that doesn't match is rejected. But if we're running those types of services or configurations, we can switch those to accept. Important to remember that the default of a standard switch is reject, allow, allow for these security policies, but the default for a distributed switch is reject, 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 high security all the time. Let's head over to traffic shaping. Traffic shaping is very similar to what we see in a standard switch. It's the ability to cap the maximum bandwidth that is available. Let's take a look at configuring these settings. We'll switch the ingress traffic shaping to enabled, and then we're going to change the peak bandwidth value to 200,000. Now the effect of doing that is setting a couple of different levels. We've got our peak level, we've got our average level, And as incoming traffic comes into the port group, not the port, but the whole port group is receiving all the different traffic from all the different VMs that are associated with it, then of course the utilization is going to go up and up and up, and eventually it'll hit this average level. If it keeps going up, that's all right. We'll move into this zone between the average and peak level. But here's the thing, we can only stay in this zone for as long as our burst holds out. So we've got a certain burst size in kilobytes, not kilobits, but a quantity of kilobytes to use up. Once that's used up, we drop straight down and we go at the average level. And over time, as we dip below that average level, then that burst size is able to kind of fill back up on a per second basis. It's pretty cool. If instead of going down, though, our levels just kept increasing up and up and up, eventually it could hit this plateau of the peak level, which controls the amount of traffic going in and out of those ports. So that's our basic traffic shaping, very cool and able to be controlled for ingress and egress. Over on the left-hand side, if we hop to VLAN and use our drop-down menu, now what we see here as none would be labeled as none on a standard switch and also given the number 0, and that typically means that what we're using is an access port on the physical switch that's associated with this, or we're using a native VLAN, an assumed VLAN on the physical switch. If you're working with a VLAN configured network, this is almost never what you want. When we choose VLAN, that would be the equivalent of actually typing a number between 1 and 4094 as a VLAN configuration number on a standard switch. And that's where we're actually sending and receiving 802.1q tagging between the switch and the virtual switch. And this is where we get a chance to put in that VLAN number. These configurations are also given terms such as external switch tagging, because the physical switch is responsible for assigning a particular VLAN number, versus virtual switch tagging, where the virtual switch, what we're looking at right here, tells the physical switch what its 802.1q VLAN tag number is. And then there's another option called virtual guest tagging. And that's what we see right here with VLAN trunking, which on a standard switch is called all and given the number 4095, because in this configuration, the assumption is that the virtual machine is actually using 802.1q tagging. Therefore, our port group needs to function as a trunk port here. So this is at the virtual switch level. And then we need to continue to just forward on that same tagging number that the VM told us all the way up to the physical switch. So this would be used if we're doing nesting or working with virtual network adapters that are actually sending their own VLAN numbers. And then we see this bottom option here of private VLAN. And this is a distributed switch only type of option. It's not available on a standard switch. Now, the beauty of private VLANs is that a particular virtual machine can have a private VLAN number, let's say it was 600, while then also having a standard VLAN number, let's say that was 10. And the reason why you have these two separate VLAN configurations is because the public VLAN is what determines the IP space, where the private VLAN determines the connection boundaries. So all the nodes that are on various different private VLANs but share VLAN 10, they're all in the same IP space. They can all point to the same default gateway. But those nodes that are in those private VLANs are either totally isolated from being able to communicate with anything other than essentially a public resource, or limited to only communicating with others in their same community. So it's all about multi-tenancy. But all of this requires configuration not only at the virtual level, but definitely at the physical level to allow for that interconnection to happen. This is not like a VXLAN where the physical network can be ignorant of the configuration. The physical network must be totally configured to the nines to match this configuration, which means there's definitely some work to be done. So if we needed to assign a particular VLAN, we can see it's easy to select that here. If we go to VLAN trunking, we have the trunking range of what is allowed for a VM to send up to me with virtual guest tagging. And if we choose private VLAN, then we have to actually go outside, configure private VLAN configuration, then come back in here and turn it on. We're going to leave it with none for now. Let's go over to monitoring. NetFlow is enabled by default. We could disable it if we don't want the monitoring to collect this data, and that's going to be important to control the amount of data going out to NetFlow, and may be important for security and privacy reasons. If we go to filtering and marking, we have the ability to click the plus here. We can actually add COS and DSCP based tags to identify certain traffic types as having come through this port group. So we can see we could drop down in here, put a check mark in DSCP value, put in a number between 0 and 63, let's throw in a 50, and then if we don't want all traffic to be tagged with that value, then we could come down here and qualify it. So we could click the green plus and qualify it by the type of traffic recognized by VMware or a MAC or IP filter. So if we come in here, then we could specifically say if it's NFS traffic that we're talking about, so not all the traffic that comes in and out of this particular port group gets tagged with the DSCP tag of 50. Instead, only the NFS traffic going through this port group gets that tag applied to it, which then can be used as a filter by other devices. And don't forget that although we've configured this here, we still haven't enabled it. That's a separate step up at the top. Let's go over to miscellaneous on the left-hand side. Block all ports. Wow, that seems pretty impressive. So yes, you can in fact go to a port group and simply shut it down as a great safety precaution to ensure that no more traffic goes through this particular port group. If you recognize there's been a security breach, maybe there's a potential virus, this is a great way to lock down that immediately. Obviously not something you would use for day-to-day business, but a great security tool. Let's go ahead and click OK. On the left-hand side, under the uplink port groups, we also have policies, not nearly as many. We can come in here, click Edit. Under the Advanced tab, we get to choose whether our uplink ports allow for override. If we go to our VLAN configuration, we can limit what VLAN numbers are available when trunking. Under monitoring, we can choose to exclude this port group from the monitoring process if we don't want that information to be passed on. The traffic filtering and marking, once again, we have the ability to enable that and then add our rules for things that are coming in and out of this uplink group that we have defined here. So the association with the physical network instead of the association with the virtual network. And then if we go to miscellaneous, once again, we can actually shut down the physical uplink group if we'd like, just like we can shut down the port group. All right, let's cancel out of that for now. So my friend, by going through this hands-on nugget together, you've learned how to configure the distributed switch policies, which is what logical switches are based on. If we don't get these right, then our transport network that's going to carry all of our VXLANs will not work correctly. So please take the time, examine these configurations in your own environment, and consider whether or not you will need to make any changes if you're in a brownfield deployment. I hope this has been informative for you, and I'd like to thank you for viewing.